Namaskar. The topic of discussion is on deep ocean trenches. Seas and oceans are very large dimension water bodies on the earth. The subject oceanography deals with the geological, physical, chemical and biological aspects of shallow and deep oceans and their processes, dynamics and natural resources. Geological oceanography is one branch which deals with the morphological and relief features of oceans, the crustal plates and their movements, the tectonic processes which are active along the plate boundaries, and the oceanic mineral or natural resources which are present in the oceans. Oceans have very distinct major and minor relief features. The bathymetric studies have given a lot of information and data to map the ocean bottom and understand the ocean relief and morphology. They indicate a lot of geological evidences to decipher the truth behind the origin of continents and oceans. Ocean morphology include many features like mid-oceanic ridges, fjords, sea mounds, plateaus, abyssal plains, abyssal hills and deep sea trenches. Ocean trenches are distributed along continental margins. They are adjacent to abyssal plains. The study of deep ocean trenches becomes a part of understanding the geological oceanography. Trenches were not clearly defined until the mid of 20th century. Due to developments in technology, bathymetric mapping of the ocean floor became possible only after the Second World War. Trenches were found to be the center pieces of convergent plate margins. A study of this is very essential due to their role in generating earthquakes. Ocean's greatest depths are found to be in trenches and troughs. Hence, in this episode, the following aspects are going to be seen: cross section of ocean basins, nature of ocean trenches, the distribution of ocean trenches, particularly the trenches in Pacific Ocean, the trenches in Atlantic Ocean, the trenches in Indian Ocean, and lastly the deepest points in oceans. Let us see the first part, cross section of ocean basins. Oceans are very large geological basins of the globe. They contain huge volume of saline water. Ocean morphology and underwater relief features are measured with reference to the depth below the mean sea level. The term hypsography refers to the area altitude analysis. The scientists E. J. Tarbuck and F. K. Ludgens have studied the elevations of the Earth's crust using hypsographic data. Their hypsographic curve shows the distribution of solid surface above and below the sea level. It is seen that about 70% of the Earth's surface is found beneath the oceans. About 30% of the Earth's surface is above the sea level. It is very clear that the volume of Earth below the sea level is many times greater than the volume of the continents above the sea level. The vertical cross section of an ocean show 5 distinct features. They are the continental shelf located adjacent to the coastline within a depth ranging from 1 to 200 meters inside the sea. The shelf region is geologically a part of the continent. The width of these shelf regions may vary from a few tens of meters to 1300 kilometers. The second one is the continental slope. It extends from the shelf with a steep topographic gradient extending from 200 meters to 2000 meters inside the sea. The boundary showing a marked change in the gradient, and it is known as the shelf break. The shelf and slope regions are cut across by unique erosional features like submarine canyons, and these submarine canyons are existing along the continental margins. They also show the occurrence of deep sea fans. The merging of many of these fans may create the continental rise. The next one is the continental rise. The continental rise extending from the slope with a depth ranging from 2000 meters to 4000 meters is located well inside the sea. The Amazon cone is one of the largest deep sea fans. It extends up to 700 kilometers northeast of Brazil. Next comes the abyssal plains. The abyssal plains are located towards the deep ocean basins with a depth ranging from 4000 meters to 6000 meters. These are followed by the deep ocean basins or ocean floors. The ocean floor is underlain by oceanic crust with many volcanic peaks. Some of these peaks that are extending more than 1 kilometer above the ocean floor are called as sea mounts. Volcanic features that are less than 1 kilometer above ocean floors are called as abyssal hills. They cover a large percentage of the ocean floor. The deepest portions of the world's oceans are found in the ocean floors. They are the ocean trenches. The oceanic trenches may have a depth ranging from 6000 meters to 10,000 meters or beyond in the ocean basins. In addition to this, ocean floors may also have very typical features like mid-oceanic ridges, volcanic islands, sea mounts, transform falls and island arcs. The rivers of continents continuously dump their sediment loads into the oceans. All decayed organic remains of the marine life also get accumulated inside the ocean floors. Waves continuously remove the sediments of coastal regions and also move them down in many zones. It is due to these factors the morphological conditions of the ocean floor will be neither permanent nor constant. It is a dynamic environment. Ocean floors are very dynamic and rapidly changing depositional environments. In addition to this, tectonic movements, volcanic eruptions and emergence of magmatic materials from the bottom of oceans may also alter the morphology of oceans. Abyssal plains are the gently sloping regions collecting all the sediments. Due to convection currents, divergent plates move away from each other. Magmatic mass emplace with force along the plate boundaries and push the plates slowly away from each other. These movements encourage an increase in the area of the sea floors and the ocean grows further. This process is known as sea floor spreading. When a plate collides over another plate, a convergent boundary is expected. Along these convergent boundaries, one plate may be pushed down the other plate. This process is called as subduction. When one plate sinks down beneath an adjoining plate in the process of subduction, a long, narrow and very deep trench may be created. Since it is inside the oceans, it is called as ocean trench. Ocean trenches are tectonically originated deep valley-like depressions. These trenches may have steep slopes at one side and gentle slopes at the other side. The depth of such trenches may go beyond 10,000 meters also. Regional compression of mass happens along the zone of subduction. A plate boundary is defined by the trench axis itself. There are two walls for a trench, as inner trench wall and outer trench wall. The inner trench wall marks the edge of the overriding plate and the outermost fore arc is in the other side of that plate. Let us see the second part, the nature of ocean trenches. It is a fact that the continents are made up of plates which are in constant motion according to the theory of plate tectonics. The convection from the earth's interior rises upwards and moves the plates apart along the divergent boundaries. At the same time, at the other end of the plate, it may collide with another plate and move downward. This boundary is called as convergent boundary. Ocean trenches are located at these convergent boundaries, where two tectonic plates collide each other. Due to this convergence, very long, narrow and deep topographic depressions are created along the boundaries inside the sea floor. The convergent movement may be at a rate of about a tenth of a square meter per second. As the convergent boundaries are the zones of weakness, volcanic eruptions occur naturally. Hence, the ocean trenches are found to be parallel to the volcanic arcs in the oceans. These may extend 3 to 4 kilometers below the level of surrounding ocean floors. The greatest known trench of the world is the Marianas Trench, which goes up to a depth of 11,022 meters below the sea level. The length may go up to 2,550 kilometers and the width may go up to 70 kilometers. The trench zones are characterized by complete darkness and unimaginable pressures due to the great depth. The pressure may go up to 16,000 pounds per square inch of the ocean floors. This is almost an inhospitable zone of deep sea for any life to stay and survive in the oceans. Deep sea trenches generally lie seaward. As said earlier, they may also be parallel to the island arcs or mountain ranges of the continental margins. Trenches are partly filled with sediments derived from the bordering continents. In most deep sea trenches, the accumulated sediments are found to be relatively less in volume, since the bottom of the trench subducts into the earth's interior. In some places, oceanic trenches may be buried below and may lack topographic expressions also. The transverse sections drawn across the trenches show asymmetric profiles with a gentle slope at one side and a steep slope on the other side. Typical slopes range between 4 degrees and 16 degrees. In some places, the slope may go up to 45 degrees also, as seen in the case of Tonga Trench of the equatorial South Pacific Ocean. The cross section of these trenches are V-shaped with steeper landward sides. If we look at the oceanward part of the trenches, the sea floor is bulged upward in an outer ridge or may rise up to 1000 meters height on the inner edge. Geophysical investigations provide important evidences concerning the origin of trenches. There is no abnormality noticed along these troughs, but all the trenches are associated with zones of earthquake foci. Along the periphery of the Pacific Ocean, earthquakes occur close to and landward of the trenches. Major earthquakes occur along the plunging boundary between the subducting and overriding plates. This boundary is called as Benioff zone. Most of the geologists argue that the size of the earth has not changed in the past several hundred million years in spite of the spreading of plates. As per the theory of plate tectonics, a new crust is generated along the divergent boundaries. At the same time, an equal amount must be destroyed at roughly the same rate to remain the area of the crust unchanged. Subduction along the convergent plate boundaries appears to maintain this geospatial balance. This process of opening and closing of the ocean basins is called as supercontinent cycle or Wilson cycle. Continental crust does not conduct heat and acts like a blanket, but the oceanic crust conducts the heat very effectively. As the ocean ages, subduction, volcanic eruption and trench formation all become inevitable and happen along with terrible tsunamis and earthquakes. A huge amount of water also gets escaped from and beneath the four arcs during subduction. Some of the Earth's most dynamic and complex interactions between aqueous fluids and rocks occur during this stage. Much amount of water is trapped in pores and fractures. sediments may enter into the trench and squeezed, forcing the fluids to come out. In some places, we get oozing mud volcanoes due to these releases. All of these fluids are dominated by water, but also contain dissolved ions and organic molecules, especially methane. Hence, trenches are ideal zones for the study of chemosynthesis. Some of the oceanic trenches are empty trenches. These are well exposed to carry out many kinds of oceanographic studies and analysis. Let us see the third part, the distribution of ocean trenches. Deep sea trenches are distributed in almost all the major oceans of the world. Altogether, about 30 major trenches and a few minor trenches have been identified by the oceanographers so far. The study of these features are very essential due to their roles in generating seismic or volcanic hazards and the birth and death of ocean bottoms. Let us see the ocean trenches of the globe. There are more trenches in the Pacific Ocean. It is to be noted that the 6 deepest trenches of the world are located in the Pacific Ocean. Let us see the oceanic trenches of Pacific Ocean. The first one is the Marianas Trench. It is 11,022 meters deep and located in the western Pacific Ocean, east of Mariana Islands, bordering the Japan Sea. It is an arcuate shaped trench. This is the deepest trench of all the oceans in the world. Guam Islands are the western side of the Marianas and the Caroline Islands are at the southern side of this. Next one is the Tonga Trench. The Tonga Trench represents a destructive plate margin. It is 10,882 meters deep. It is located near Tonga, west of Cook Islands and east of Fiji Islands. The Philippine Trench is located at the east of Philippine Islands. It is 10,540 meters deep. The Kuril-Kamchatka Trench is located near Kuril Islands, south of Kamchatka. It is 10,500 meters deep. The Kermadec Trench is located northeast New Zealand and south of Tonga Trench. It is also seen like an extension of Tonga Trench or vice versa in the oceans. It is 10,047 meters deep. The Izu Ogasawara Trench is located near Izu and Bonin Islands. It is 9,780 meters deep. The Japan Trench is located in the northeast Japan. It is 9,000 meters deep and it is flanked by Bonin Trench on the left and Kuril Trench on the right. The Yap Palau Trench is located between Palau Islands and Mariana Trench in the western Pacific. It is 8,527 meters deep. The Aleutian Trench is located at the west of Alaska and south of Bering Sea and Aleutian Islands. Its mean width is 50 kilometers and length is 3,700 kilometers. It is 7,679 meters deep. The Peru-Chile Trench is a destructive margin situated bordering the west coast of South America. It is located in the East Pacific Ocean off coast of Peru and Chile. Its mean width is 100 kilometers and length is 5,900 kilometers. The Middle America Trench is located in the eastern Pacific Ocean off coast of Guatemala, Costa Rica. This trench is in the middle of North and South America. It is 6,669 meters deep. Its mean width is 40 kilometers and the length is 2,800 kilometers. The Peiseger Trench is located southwest of New Zealand. It is 6,300 meters deep. The Vitias Trench is located near Santa Cruz Islands. It is 6,150 meters deep. The Ryukyu Trench is located along the eastern edge of Japan's Ryukyu Islands between Taiwan and Japan. It is 5,212 meters deep. There are also smaller trenches like New Britain Trench, Solomon Trench and New Hebrides Trench. The Solomon Trench and the New Hebrides Trench are looking like a continuous chain of trenches. If we look at the bathymetry of the Pacific Ocean, Yap Palau Trench, Marianas Trench, Bonin Trench, Japan Trench, Kuril Trench, Ryukyu Trench, Philippine Trench and Aleutian Trench are all in a chain like network. The Northwest Pacific is a critical zone having all the mega trenches of the world. In contrast to the more number of trenches of the Pacific Ocean, there are only 3 major trenches located in the Atlantic Ocean. It is mainly due to the fact that the Atlantic has the divergent plate boundaries in the middle. The Puerto Rico Trench in North Atlantic is an important one. It is 8,605 meters deep. This forms the boundary between the Caribbean Sea and the Atlantic Ocean. Next comes the South Sandwich Trench. The South Sandwich Trench is 8,428 meters deep and is located in the South Atlantic Ocean. It is 100 kilometers long to the east of South Sandwich Islands. It belongs to a volcanically active zone. The Romanche Trench is located near the equator and reaches a depth of 7,760 meters. The Indian Ocean has also a few oceanic trenches. They are, let us see the first one, the Java Trench. The Java Trench is 7,455 meters deep. People formerly named it as Sunda Trench. It is located at the northeast of Indian Ocean bordering Sumatra and Java region. The Diamantina Deep is yet another trench of the Indian Ocean. It is 8,047 meters deep. The Ope Trench, Sunda Trough, Amirante Trench, Timor Trough, New Guinea Trench are also existing in the Indian Ocean. The Mauritius Trench is located south of Mauritius Islands. The Chagos Trench is extending from Maldives. Let us see the fourth part, the deepest points in the oceans. Similar to the variation of relief features on continents, oceans too show a very wide variations in their relief features. As we get peaks as highest points of mountains on the land, we have the deepest portions in the ocean floors. These are called as deeps. There are also some notable ocean trenches in the other minor seas and bays. They are the Cayman Trough located in the Caribbean Sea. It is 7,686 meters deep. The Litke Deep of the Eurasian Basin in the Arctic region is yet another one. It is 5,450 meters deep. It is located in northeast Greenland. The Manila Trench is in the South China Sea. It is 5,400 meters deep. The Calypso Deep is in the Mediterranean Sea. It is 5,267 meters deep. The Hellenic Trench is in the Cape Metapan region. It is 4,500 meters deep. The 6B Deep is in the Gulf of Mexico. It is 4,384 meters deep. The Central Trough is located in the Red Sea. It is 2,211 meters deep. The Winnisk Trough is located within the Hudson Bay. It is 370 meters deep. This may be probably the smallest trench of the world. The world's oceans have the following deepest points. The Challenger Deep is the deepest point of the world. It is in the Marianas Trench, having a depth of 11,022 meters on the floors of Pacific Ocean. The Richards Deep is the second one. It is in the Peru-Chile Trench. Its depth is 8,065 meters. The Milwaukee Deep is in the Puerto Rico Trench, north of Puerto Rico. Its depth is 8,530 meters. The Litke Deep is in the Arctic Ocean. It has a depth of 5450 meters. The ecobiological and geochemical conditions of these unique zones are to be studied in detail. The understanding of the deep sea life and other conditions form the basis for exploring the potential of oceans. Let us see some more details of oceanography in the forthcoming episodes.